Before formulating your research hypothesis, read out the topic of interest to you. From your reading, which may include articles, books, and cases, you should gain sufficient information about your topic that will enable you to narrow or limit it and express it as a research question. So once you have identified your research question, it is time to formulate your hypothesis. Now, what is hypothesis? Hypotheses can be considered as intelligent hunches, guesses, or predictions that help researchers seek a solution or answer a research question. More precisely, a hypothesis is a statement about the relationship between two or more variables that suggests an answer to the research question. A hypothesis is a declarative statement, by the way, that predicts an expected outcome. So it explains or predicts the relationship or differences between two or more variables in terms of expected results or outcomes of a study. Though there are no hard or fast rules for formulating hypotheses for a study, but there are a few things that you should keep in your mind. So criteria are following. First one is independent and dependent variables to be studied can be identified. So you should not select in the variables which cannot be identified. So that's the first condition. Now, second condition is the nature of the relationship that exists between the variables can be specified. Third one is they are related to the existing body of theory and impact. And fifth one is testable and falsifiable. It's always better to have several simple hypotheses than a complex one. However, it is also a good idea to limit the number of hypotheses you use in a study to 6 or fewer. Studies that embrace more hypotheses than 6 will often be too time consuming to keep participants interested, and uninterested participants do not take the importance of their responses as seriously. Hypothesis is a statement that specific relationship you expect to find from your examination of the variables associated with the research or questions. The research questions, when stated as one sentence and clearly, is your research hypothesis. There are two types of hypothesis. First one is null hypothesis, which is denoted as H0. A hypothesis that states that there is no difference between a parameter, for example, population mean, which is denoted as mu, and a specified value, says 80, etc. Or that there is no difference between two parameters like dependent variables, for example, profit, and independent variable means investment. Now, here I tend to say is that, suppose, what do you think that if you invest somewhere, what do you think about your profit? Suppose you already have 2 units, so you have invested on third unit in the product line. Now you should expect that your profit will be increased, right? That's why you have invested. So that's why people usually invest to earn profit. But null hypothesis that even after investing, there will be unchanged profit. So it will not bring, your investment will not bring any changes in your profit. So basically it means to say that. Now, second one is alternative hypothesis, which is denoted as H1 or HA. So alternative hypothesis is a hypothesis that tests the existence of a difference between a parameter and a specific value, or states there is a difference between two parameters. Dependent variable is profit and independent variable is investment. So alternative hypothesis is created in a negative meaning to the null hypothesis. So what null hypothesis tests, the alternative hypothesis states quite opposite. So alternative hypothesis says that if you invest, there will be changes in your profit. Your profit can be increased or your profit can be minimized, but it will not remain same. So this is what alternative hypothesis tends to say. Now that we have talked about population and parameter in the above slides, so what are that? What are those, and what are the differences between parameters and statistics or samples? So population, when you talk about parameter, we mean the population. A population is a whole, is every member of a group. So a statistical population is a set of all the entities of a kind. For instance, all the people of a country is called population. And when we talk about population, we denote the mean as mu. As it is impossible to observe the entire population because of its huge number, due to time constraints, of geographical accessibility and constraints on other researchers' resources, a researcher would instead observe a statistical sample from the population in order to attempt to learn something about the population as a whole. When we talk about statistical sample, the mean is denoted as x bar. You have to remember that while formulating a hypothesis, you have to understand that whether it is all about a population or it's about a statistical sample. If it's a population, then you have to use mu as mean, and if it's from a statistical sample, then you have to use x bar for mean. Okay, let's move on to hypothesis testing. Every hypothesis test requires the analyst to state a null hypothesis and an alternative hypothesis. As we talked about all this null hypothesis and alternative hypothesis before, the hypotheses are stated in such a way that they are mutually exclusive. Okay, that is, if one is true, the other one must be false, and vice versa. Let's see a situation. The first situation, it is stated that the mean entry salary of an IT graduate employee at a mid-level company in Bangladesh is Taka 28,000, said by your friend Mr. Ali from a literature. As an IT professional, you don't believe in the stated salary for an IT graduate in the company. How can you justify your assumption? Now state the null and alternative hypothesis. Suppose we want to test this hypothesis. Okay, null hypothesis is that there is no difference between the population parameter. Okay, here the population mean is mu. Okay, and the specified value here means salary is 28,000. Therefore we can say that the population mean is equal to the hypothesized mean, I mean salary, and symbolically we can express it as H0 means null hypothesis, mu is equal to 28,000. Okay, therefore alternative hypothesis says the opposite of null hypothesis. That's why is H1 mu is not equal to 28,000. Now this mu can be more than 28,000 or less than 28,000. Okay, so now you survey a represented number of IT companies through interview questionnaires and search payrolls and find that an average salary is 35,000. Okay, so we can reject the null hypothesis or accept the alternative hypothesis in this case, because null hypothesis says that it's exactly 28,000, but you have found out that the average salary is 35,000. So you reject your null hypothesis and accept your alternative hypothesis. Okay, now let's see situation 2. The mean entry level salary of an IT graduate employee at a mid-level company is in Bangladesh is at most 28,000 taka. So at most means maximum. Okay, can be less than but not more than 28,000, said by your friend Mr. Ali through some literature research. As an IT professional, you don't believe that the stated salary for an IT graduate in the company state the null hypothesis and alternative hypothesis same, but in the previous situation it was told that it was exactly 28,000, but in this situation it is told that the salary should be at most 28,000. So can be 28,000 and less than 28,000 but not more than 28,000. Okay, now null hypothesis says that mu is less than or equal to 28,000 because it said at most. Okay, therefore alternative hypothesis says the opposite of null hypothesis, which is mu greater than 28,000, because alternative hypothesis should be opposite to null hypothesis. Here null hypothesis says that mu is less than or equal to 28,000. In the choice of hypothesis, the following considerations are usually kept in view. First one is alternative hypothesis is usually the one which one wishes to prove, and the null hypothesis is the one which one wishes to disprove. Thus, a null hypothesis represents the hypothesis we are trying to reject, and alternative hypothesis represents all other possibilities and accepted. Second one is null hypothesis should always be a specific hypothesis. For example, it should not be stated about or approximately a value. It should be an exact value. Third one is in testing hypothesis, there are two possible outcomes. First one is reject null hypothesis and accept alternative hypothesis because of sufficient evidence in the sample in favor of alternative hypothesis, and second one is do not reject null hypothesis because of insufficient evidence to support alternative hypothesis. Okay, let's know about two-tailed and one-tailed hypothesis tests. What are they? The table you're seeing shows three sets of hypotheses. Each makes a statement about how the population mean mu is related to a specified value of m. So here first set one, null hypothesis says that mu is equal to m, and alternative hypothesis says that mu is not equal to m. This is a two-tailed hypothesis stage. How? See that here it says that mu is not equal to m, so it means that mu should be less than m, and or mu should be greater than m. Okay, that's why two-tailed, because it's showing two sides. There's possibility of two sides, either it can be less than m or it can be greater than m. Two sides, that's why two-tailed. Simple. And second set says that mu greater than m. Alternative hypothesis says mu is less than m. So here it says that mu should be less than m. It cannot be equal or greater than m. So it shows you one side of the possibility. That's why it's one-tailed. Third one, same, mu is less than m. Null hypothesis says, and alternative hypothesis says mu is greater than m. This is one-tailed hypothesis test, because it doesn't show you the other side, because if it's accepted, then it should be mu greater than m. Alternative hypothesis will be accepted when mu should be greater than m. There's no possibility that it can be equal or less than m. Okay, so this is all about one-tailed and two-tailed hypothesis. Now, how do you get that whether to accept or reject hypothesis? Which hypothesis should be accepted and which hypothesis should be rejected? So it is identified by the p-value. The p-value approach to hypothesis testing using the calculated probability to determine whether there is evidence to reject the null hypothesis or not. So if p-value is greater than 0.05, 0.05 means 5% in the probability that the null hypothesis is true. If p-value is greater than 5%, 1 minus the p-value is the probability that the alternative hypothesis is true. So 1 minus p-value here, suppose 1 minus 5% is equal to 95%. So this is the probability that alternative hypothesis is true. A statistically significant test result p less than or equal to 5% means that the test hypothesis is false or should be rejected. And a p-value greater than 0.05 means that no effect was no effect was observed. So it says that null hypothesis is true. Look at the first one. P greater than 0.05 is the probability that the null hypothesis is true, and null hypothesis says that the impact will be unchanged. Okay.